For this video, we will solve problems involving polynomial equations and the Vieta's formula. But before that, I have here a polynomial equation and I want you to identify the roots of this equation. You can pause this video while solving and play once you're done. The roots of the equation are 1, 3, and -2. Now, let 1 be the first root or r sub 1, 3 be the second root or r sub 2, -2 as the third root or r sub 3. What is the sum of the roots of this equation? Since we are given 1, 3, and -2 as our roots, therefore r sub 1 plus r sub 2 plus r sub 3 is equal to 1 plus 3 plus -2, which is equal to 2. How about if we get the sum of the product of two roots of this equation? The possible combinations that we can have are r sub 1 times r sub 2, r sub 3 times r sub 2, r sub 1 times r sub 3. We add them, we will have -5 as the sum. This time, let's get the product of these roots. So, r sub 1 times r sub 3 times r sub 2, we will have -6. Did you notice anything on the sum and product that we solve in relation to our given equation? Look at our answers and look at the numerical coefficients of our given equation. Maybe there's a pattern. So therefore, there is another way of solving this roots or the sum of these roots or the product of these roots without even getting the roots of the original equation. Yes, there is. And that is through the use of the Vieta's formula. The Vieta's formula is used if you want to get the sum of the products of distinct roots of a polynomial taken I at a time. The Vieta's formula states that S sub I is simply equal to -1 raised to I times the quotient of a sub n minus 1 divided by a sub n. So, what does this formula technically mean? So if we have here S sub 1, it is simply adding all the roots of distinct roots of a polynomial equation. If we have S sub 2, we are simply looking for the sum of all the roots, the product of the distinct roots taken two at a time. S sub 3 is simply the sum of the products of distinct roots of a polynomial taken 3 at a time. And so on for S sub 4, S sub 5, and S sub 6. So therefore, if we have a quadratic equation, if we want to get the product of the roots, we will have S sub 2 until S sub 2 only, because we only have two distinct roots for quadratic equation. And for cubic equation, we only have until S sub 3. Okay? And S sub 3 is simply the product of the roots of the given polynomial equation or given cubic equation. And so on for S sub 4, S sub 5, and S sub 6. It means that you cannot get S sub 4, S sub 5, S sub 6 if the degree of the polynomial is only 3. So you only have until S sub 3. And so on for other polynomials. Now, let's try to solve problems involving the Vieta's formula and of course, polynomial equations. So for the first example, what is the sum of the roots of the equation 3x cubed plus 9x squared plus 4x plus 12 equals 0? So, instead of getting the roots of the equation, we can just simply apply the Vieta's formula. So we have S of 1, since we're only going to get the sum of all the roots, distinct roots of this equation. So substituting, we have S of 1 is equal to negative 1 raised to 1 times a sub 3 minus 1 all over a sub 3. So that would be negative 1 raised to 1 times a sub 2 over a sub 3. Substituting. What is a sub 2 in this equation? That's 9. A sub 3 is simply the leading coefficient, or that's 3. So, substitute, we will have S of 1 is simply equal to negative 1 raised to 1 times 9 over 3. Negative 1 raised to 1 is negative 1, and 9 over 3 is equal to 3. So, negative 1 times 3 is equal to negative 3. Next question. What is the product of the roots of the equation x to the 5th plus 2x to the 4th plus 11x cubed plus 22x squared plus 24x plus 48 equals 0? If I'm going to find the roots of this equation, it would be a little difficult since I have 5 roots to look for. So, if I'm just going to get the product of the roots, I will just simply use the Vieta's formula. So that would be S of 5. So, S of 5 is simply equal to negative 1 raised to 5 times a sub 5 minus 5 all over a sub 5. A sub 5 minus 5 is simply a sub 0 over a sub 5. A sub 0 is our constant term, and a sub 5 is our leading coefficient. But we don't see the leading coefficient, so technically it's equal to 1. Substitute the formula, we will have S of 5 is equal to negative 1 raised to 5, which is negative 1, times 48 over 1, which is equal to 48. So negative 1 times 48 over 1, or 48, is simply equal to negative 48.